Hi there, today we're going to be looking at percentages. We're going to start with looking at the meaning of percentage, and then we're going to be looking at some conversions between fractions, decimals and percentages. You'll see the three-letter acronym FDP quite often when it comes to fractions, decimals and percentages. So let's get started. We see percentages everywhere. We see them in shops, places like Sports Direct with a percentage discount. We see maybe in banks with interest rates for borrowing money or for saving money. And we'll often see percentages in the news as the way of describing something, maybe the change in something, perhaps the percentage increase or decrease in a statistic. So we see them a lot, but it's really important that we understand what they mean. Firstly, let's just talk about what it looks like. So we write 20%, for example, is written as 20%. I'm sure most of you have seen that percentage sign. But what does percent actually mean? Percent means per 100 or out of 100. So in a maths test, if you get 80%, you've got 80 questions correct out of a total of 100 questions, perhaps. Okay, so therefore 20% in this case means 20 out of 100. Okay, and we can write this as a fraction, which we can write as a fraction. We would write it as 20 out of 100. Obviously that can therefore be simplified down, but we're going to leave it like that at the moment because, and this is a really important point, I'm going to put this in one of our learning bubbles, a percentage is a fraction with 100 as the denominator, and you must accept my apologies if I was a little bit distracted then. My daughter just came running down the stairs and was saying hello to the dog, and was a little bit loud and I was a little bit distracted, so apologies if you heard that. So okay, so a percentage is a fraction with 100 as the denominator. So for example, 20 over 100. You might know that that simplifies down to 1/5, but we write it with 100 as our denominator. Right, I want to take a look at a couple of examples here. Again, nice and simple, nice and straightforward. I've just drawn a grid here, a 10 by 10 grid. So I've got 100 squares here, just going back to that concept, just reiterating it and showing it visually of it being out of 100. So if I take an example of, say, 23 over 100, well, that would therefore mean I've got 23 of my squares shaded out of 100 in total. Okay, so 23 out of 100, 23 of my squares shaded out of 100 in total. Okay, what about if I had 100 squares shaded? Well, that's nice and easy, isn't it? For my colouring, I can just shade them all in now. So I've got all 100, there you go, not missed any out, all 100 of my squares shaded. So I can now say that 100% of my squares are shaded, so 100% represents the whole amount, or 1. So let's write that down again as a key point. If all squares are shaded, we can say that 100, because all of our squares are shaded, 100% of squares are shaded. So 100% represents the whole amount. And we can write that 100% is my percentage. It's equivalent to 100 over 100 as a fraction, which is 1. All right, there's my learning bubble there. If all squares are shaded, we can say that 100% of squares are shaded. So 100% represents the whole amount. 100% equals 100 over 100, which equals 1. But what if it wasn't out of 100? What if it was only out of, I don't know, let's say 10? What do I do now to turn this into a percentage? I know from up here, let's go back up again. A percentage is a fraction with 100 as the denominator. Okay, that's a clue. I need to make my denominator 100. Well, luckily, from doing my equivalent fractions, I know that if I multiply my denominator by 10, I'm going to get a denominator of 100. I know for equivalent fractions, I need to do the same to the numerator that I do to the denominator. So I'm going to multiply both of them by 10. That gives me 30 over 100, which I can now write as 30%. Perfect. I've used equivalent fractions to make the denominator 100. We're going to come on to a second method a little bit later. Here's a question for you. Can a percentage be greater than 100%? Can a percentage be greater than 100%? Now, this can sometimes be confusing, particularly if we look at a diagram like this and we say, well, all of my squares are shaded. My whole is shaded and therefore I've got 100%. How can I have more than 100%? Well, let's just think about fractions for a moment. Let's take an example of a mixed number fraction. I'm going to choose 1 and 1/10. I know that I can write my mixed number fraction as an improper fraction. That would be 11 over 10. 1 multiplied by 10 is 10 plus 1 gives me 11 over 10. Right, let's go back up to my rule at the top again. A percentage is a fraction with 100 as the denominator. So I now know from here I need to use equivalent fractions to make my denominator 100. So I can multiply my numerator and my denominator by 10. Let's have a look and see what I've got. I've now got 110%. So yes, a percentage can be greater than 100%. And that's one of those common misconceptions that people have, that they think you can't go beyond 100%. So let's look at a couple of examples. Firstly, I want to look at converting a fraction to a percentage, which is what we've done here, but I just want to set it out because we've got a couple of different methods we can use depending on the numbers that we're looking at. So I'm going to put question 5 here. I'm going to put a little subheading here. Convert fraction to percentage. Right, so we've talked about making the denominator 100. So I'm going to call that method 1. Make denominator 100. And we know that we're going to achieve that by using equivalent fractions. So let's look at this. Sorry, put that there. Question 5. If I've got 1/4 and I want an equivalent fraction with 100 as the denominator, now I'm going to go straight in there and say that I can multiply my numerator and my denominator by 25. If you can't see that, then you can build it up more slowly. Maybe you could multiply by 5 first to get 20 and then multiply by 5 again. But I'm going to go straight in there with 25 over 100, and then I can write that as 25%. I'm going to do a mixed number example. I've got 3 and 1/5. I'm going to turn it into an improper fraction. Now 3 multiplied by 5 is 15 plus 1 gives me 16 over 5. Now I need to use my equivalent fractions. I need to get from 5 to 100. Maybe I could just go straight in there and multiply by 20. But let's double it first to perhaps make it a little bit clearer and get 10 as my denominator. And now it's fairly straightforward to see that if I multiply my numerator and my denominator by 10, I'm going to get a denominator of 100, and therefore we can see again that I'm going to have a percentage greater than 100%, and that is absolutely okay. I just want to show you one other way. I'm going to call this method 2, because we might find a situation where I can't convert my denominator into 100. So I'm going to call this the division method. And probably the simplest example I can think of with this one. For method 2, the division method, we need to look, we cannot make the denominator 100, so we need to look at this calculation here. 1 divided by 3, I can write as 1 divided by 3, and I can use a little bit of short division. Let's do that over here. So I've got the number 1, and I want to divide it by 3. 3 doesn't go into 1. I make sure I line up my decimal point. I'm going to carry that 1 here. 3 goes into 10. 3 times remainder 1. 3 times remainder 1, etc. Okay, so that gives me a decimal. So at this point, I've converted it into a decimal of 0.3 recurring. Let's just put that in a quick learning bubble as well to say that 0.3 with the dot over the 3 means that the 3 is recurring, i.e. it goes on forever. That's what recurring means. It goes on forever. So just a quick little learning bubble there. It goes on forever. So what I've done at this point is I've converted it into a decimal. I want it as a percentage. So I now need to take my 0.3 recurring. Remember, that's what that means. So I'm going to write it out a little bit more in full this time to 3 decimal places. And to convert from a decimal to a percentage, and I'm just going to go through that again in a moment as well, I multiply it by 100. That's going to give me 33 0.3% to 1 decimal place, or I can put my recurring dot there that tells me the 3 goes on forever. Okay, so that's how we get a percentage when we cannot easily convert our denominator into 1. There is another way you can do it. We would just fast track it a little bit. Is you can do 1 divided by 3 multiplied by 100 over 1. Then you would just do exactly the same thing with your short division. This brings you straight into a percentage rather than going to a decimal first. So you would have 100 this time that is being divided by 3, and you would end up obviously with 33, and then the same thing, you would just keep carrying and you'd get the 0.3 there. Okay, so that's just an option as well, that you go straight in with your percentage there rather than converting to a decimal first. Okay, now let's look at, so we've done converting fractions to percentages. Let's look at going back the other way. We're now going to go from a conversion from a percentage back to the fraction. Okay, so from the percentages to fractions. A couple more quick examples. Question 8. If we had 12%, then we know that a percentage is a fraction with 100 as its denominator. So I can write that as 12 over 100. And now I can simplify that down using equivalent fractions to 6 over 50. And I can simplify that again to 3 over 25. So simply dividing the denominator and the numerator by 2 and then by 2 again, or again I could have divided by 4 straight away. One more example, remembering that we can have percentages greater than 100%. We would have 123 still over 100. That would give us a mixed number fraction of 1 and 23 over 100. Okay, in this particular case, I can't simplify it, so I just leave it as it is. Now let's look at converting decimals to percentages. We talked about that briefly above. When we looked at 1/3. Okay, so we can use 2 different methods. I tend to prefer the second method, but I'll show you both. Method 2, using equivalent fractions. You'll often find in maths there's multiple different methods, and you can use the method that you prefer or best suits the question. So, for example, we have 0.3. I've got the number 3 in the tenths column. So the number 3 in the tenths column. So I have 3/10. I then turn it into 30 over 100. And therefore I know my percentage is 30%. The other method is we simply multiply by 100. Now, for those of you who have listened to some of my other lessons, you know that we can also call this the Beyonce method. When we multiply it by 100, we move the place value to the left 2 times, to the left, to the left. And again, you are not going to get me to sing it. So, question 11, we've got 0.3 multiplied by 100 gives us 30%. Nice and straightforward, as long as we remember that we multiply by 100 to get a percentage, because percent means out of 100. Right, we just need to look at now converting percentages back to decimals. Let's get a new page. Converting percentages to decimals. Nice and straightforward. So if we start, what question number am I on? Sorry, question 12. If I start with 40%, I know that that is 40 over 100. I can simplify that down to 4 over 10. I do not want to simplify it any further. I want my denominator to be 10, 100 or 1000. And then that allows me to say I've got the number 4 in the tenths column. So my answer is 0.4. Alternatively, exactly the same as the two different methods previously, I could do 40 divided by 100. Moving the place value twice to the right is going to give me 0.4. The last thing I want to do in this video is just mention a few common FDP, fraction, decimal and percentage conversions. And I would say the more of these that you can memorize, the easier you're going to make your life, because it means for a number of questions, you'll just know what the conversion is. You don't have to calculate it each time. So I'm just going to do a few. You can probably set it out far more neatly than me, because I'm just going to do it very quickly. Fractions, decimals and percentages. 3 quick headings. And then I'm not going to do, obviously, loads. I'll just do a few key ones that sort of tend to come up again and again. So if we start with, say, 1 over 20, I can convert that into a decimal. I know that that's going to give me 5 over 100. So the number 5 in the hundredths column is 0.05, and as a percentage, it's going to give me 5%. Let's look at 1/10. Again, I can write that as 10 over 100 to get my percentage. 1 in the tenths column gives me my decimal, and 10 over 100 gives me my percentage. Let's look at 1/8. Now for this calculation, I would use a quick bit of short division. So I'd say I've got 1 and I'm dividing it by 8. So 8 doesn't go into 1, 8 goes into 10 once, remainder 2, 8 goes into 20 twice, remainder 4, and 8 goes into 40 5 times. That gives me 0.125. Much easier if you just commit that one to memory, and as a percentage it's going to give me 12.5%. If I look at 1/5 now, 1/5, I can write that as 2 over 10. I've got the number 2 in the tenths column, that gives me my decimal, and 20 over 100 is going to give me my 20%. 1/4, we've already done that one, but I'll write it down for completion. That was 0.25 and 25%. 1/3, we have also done. It was 0.33, that's to 2 decimal places, and 33.3, or remember you can put the dot above the 3 to show that it's recurring. And finally, let's finish off with a nice easy one, 1/2, which I can write as 5 over 10. The number 5 in the tenths column tells me that it's 0.5. And if I want the denominator to be 100 for my percentage, 50 over 100 gives me 50%. if I was in the classroom, I would set you a homework challenge of trying to memorize all those conversions. So please try and commit them to memory. It will make your life much easier. Thanks very much for your time.